Practice problems. Name two triangles that are congruent by angle, side, angle. Now, the answer for number one, you have to have two angles. You have to have two angles, and this is called the included side. That is called the included side. So if you notice, this side is congruent to this side, this angle is congruent to this angle, and angle I is congruent to angle L. So therefore, triangle 1 and triangle 2 are congruent. So now we got to write the statement. And these are the two angles, and that's the included side. So we have triangle, order matters, H, I, J is congruent with triangle. Now H has to correspond with, and let me erase this because I know, H has to correspond with M, and I corresponds with L, and K corresponds with J. So these two triangles are congruent because of the angle, side, angle postulate. If you see number 2, you have 3 triangles, and the third triangle you can't see, but this is one side, and then we have 2 markings. So we have U, and I think this is a right triangle. So we have this side is congruent with this side, this angle is congruent with this angle, and angle S is congruent with angle Z. So therefore, these two triangles, angle 1 and angle 2, triangle 1 and triangle 2, are congruent. The third triangle doesn't have the other angle, which is angle U, congruent to the other two angles. So to write the statement, you're going to have triangle STR is congruent with triangle S corresponds with Z, Z, T corresponds with X, so that's X, and then R corresponds with Y. So these two triangles are congruent because of angle, angle, side, angle. And we look at 3, we have 3 different triangles, so we have to sort this out. We know by just looking at this, we have angle Q and angle U are congruent. I know that angle T is congruent with angle R, and we do have the included side. So the only 2 triangles that can be congruent because of ASA are triangle 1 and triangle 2. So I'm going to write the statement. So we have triangle SRQ is congruent to triangle. So remember, order matters. So we have S is corresponding with V. We have R is corresponding with U. And we know that Q is no, I take that back. Q is corresponding with, we have S corresponding with V. We have R corresponding with T. So let me make the correction here. This is T, and the last one is U. And we're going to say because of ASA, angle, side, angle postulate. Now, if we look at 4, we have 3 triangles. We do have a right triangle. We do have a right angle. We have a right angle. We have 3 right angles. This is the included side. This is the included side. This is the included side. And of course, this is the other angle. This is the other angle. And this is the other angle. And I don't know if you can see the statement. It's right here. Triangle IGH is congruent with triangle ROQ, which is congruent to triangle PMN. So I identified all the triangles that were congruent using angle, side, angle. We are going to do some proofs. We're given information. This is the information that's given. I'm going to go ahead and do the markings. Angle LOM, which is this angle, is congruent to this angle that's given. And segment LN is congruent to segment NM. So the first statement is given, and the goal is to prove that those two triangles are congruent. Now you notice that this angle is congruent to this angle, right? we have angle, angle, side. So the reason why these two triangles are congruent is because angle, angle, side. That means we have a corresponding angle congruent, we have another corresponding angle congruent, and then we have a side that's congruent. Before we skip to the end, we have angle LMO is congruent to angle NMP, and that's by definition of vertical angles, because we know that all vertical angles are congruent, right? And that's the answer to number 1. That's the proof. Number 2, we're given angle B, and we're also given angle D are right angles. We know that line AC bisects BD, so it makes two congruent segments. And we know that this angle is congruent to this angle because those are vertical angles. So let's go ahead and fit in, let's give the reasons to our statements. We're trying to prove that this triangle is congruent to this triangle. So angle B and angle D are right, and segment AE bisects segment BD. That's given. BC, segment BC is congruent to segment DC. That's definition of segment bisector. Segment bisector. We know that the measurement of angle ABC and the measurement of angle EDC are 90. That's by definition of a right angle. And we have two corresponding angles, and we have the included side that are congruent. So these two triangles, angle ABC is congruent to angle EDC. That's definition of vertical angles. Angle ABC, ACB, this one is definition of vertical angles, and the one before that was definition of right angles again, because the angles are 90 degrees, so therefore they're congruent. Now, the final statement, triangle ABC is congruent to triangle EDC, because of we have an angle, an included side, and included angle, a pair of those. So it's going to be because of angle, side angle, postulate.